Hello and welcome to Chapter 7 of our Artificial Intelligence course. I am Jose Antonio Menendez. Throughout this course, we have studied how AI can understand language, analyze information, and improve productivity. In this chapter, we take the next important step. We are moving from AI that only gives us an answer to artificial intelligence that can help us complete an objective. This is the world of AI agents. A traditional chatbot waits for a question and produces a response. An AI agent is different. It receives a goal. It can analyze the situation, create a plan, select tools, execute several steps, and evaluate the results. For example, instead of merely asking, "What invoices are overdue?" we could give an AI agent a more complex objective. Review all open invoices, identify those more than 30 days overdue, and verify whether the customer has disputed any of them. Prepare personalized reminder emails and send the drafts to the accounts receivable manager for final approval. The second request is not simply a question. It is a workflow involving retrieval, analysis, and human authorization. That is the central idea of this chapter. Generative AI creates content. Agentic AI coordinates actions toward a goal. So, what is an AI agent? It is a software system that uses an artificial intelligence model to pursue a defined objective. It can observe information, reason about what it finds, select an appropriate action, and use available tools. Every agent needs a goal. Examples include resolving customer support requests or researching potential suppliers. It might monitor inventory to identify shortages or review shipment documents for missing information. A vague goal produces vague behavior. A well-defined goal includes the expected output, constraints, and available data. Component 2 is instructions. These define how the agent should work, its role, and its permitted or prohibited actions. For example, identify discrepancies but never approve or schedule a payment. Refer all large discrepancies to a supervisor. The third component is the model. The language model provides the reasoning, interpretation, and classification capabilities. The model can analyze unstructured information such as emails, contracts, PDFs, reports, and customer messages. It can also process meeting notes, technical documentation, images, and even scan forms as the reasoning engine. The model is the reasoning engine, but it is not the entire agent. It needs instructions and tools to complete workflows. Component 4 is tools. Tools allow the agent to interact with systems outside the language model, like databases and accounting apps. These might also include internal APIs, logistics platforms, or code execution within controlled workflows. Component 5 is memory, or state. Agents often need to remember what has happened during a task. For a shipment agent, this means remembering the importer, shipment number, and documents already received. Without state, the agent may repeat actions or lose context on questions previously sent or decisions approved. Finally, Component 6 is evaluation. An effective agent must determine whether its action was successful. It should verify if documents are current, complete, and satisfy the specific company requirements. Evaluation transforms an action into a controlled process. It ensures accuracy at every stage of the workflow. These terms are often used interchangeably, but they represent different levels of capability. Let's examine them. Level 1 is the chatbot. It responds to messages like explaining the difference between gross and net profit. The interaction normally ends with the response. It answers the question, and the task is done. Level 2 is the AI assistant. It supports a person across multiple tasks, like summarizing reports or drafting emails. However, the human generally directs each major step. The assistant performs the task as requested by the user. Level 3 is traditional automation. It follows predefined rules, like reading fields and entering data into accounting systems. This automation is efficient, but it may not adapt well to unusual or complex situations outside its rules. Level 4 is the AI agent. An agent receives a goal and determines some or all of the steps required to achieve it. The agent reviews order history, consults policies, determines a response, and escalates cases when needed. That is coordinated action. A simplified agent cycle can be represented as observe, understand, plan, act, evaluate, and continue or stop. Consider a shipment agent. Step 1 is observe. The agent retrieves the invoice, packing list, and bill of lading. Step 2 is understand. It extracts important information: names, dates, currency, and product quantities. Step 3 is plan. The agent decides to reconcile values and check if descriptions are detailed enough for classification. Step 4 is act. The agent performs comparisons and searches authorized internal sources to identify any missing info. Finally, step 5 and 6, evaluate, then continue or stop. It determines if the file is ready for entry preparation. The agent supports the process, but accountable professionals retain responsibility for regulated decisions like customs entries. Not every problem requires an autonomous agent. This distinction is extremely important for system design. A workflow follows a mostly predetermined sequence. It's predictable, like extracting fields and comparing invoice totals. An agent approach involves uncertainty and adaptation, deciding which policy applies or investigating complex mismatches. The best system is the simplest one that can reliably complete the objective. Autonomy must be justified by value. An organization may use one agent or several specialized agents. Let's look at the differences. A single agent system manages the complete task. It is easier to understand, monitor, and maintain. A multi-agent system divides work among specialists. A lead agent might assign work to parallel sub-agents. This includes verification agents to identify unsupported conclusions. It increases coverage, but also adds coordination costs. The correct strategy is, start with one controlled agent, validate performance, and add specialists only when needed. Let's examine how agents can be applied in different industries, from customer service to manufacturing. A customer service agent resolves routine questions while escalating sensitive cases like legal threats or safety issues. Sales agents identify ideal customer profiles, confirm location, and prepare email drafts for human approval. In manufacturing, quality agents monitor defects and machine downtime, identifying patterns to recommend maintenance. An executive agent collects data across departments to produce performance indicators and recommended management actions. A useful agent specification should answer 7 critical questions to ensure both capability and control. First, what is the objective? Second, what information can the agent access? Define the data boundaries clearly. Third, what tools can it use? And fourth, what actions are prohibited, like deleting records or changing banking info? Finally, determine when humans must approve, how success is measured, and how the agent will be monitored. Here is a reusable template to define an agent's role, objective, data boundaries, and escalation rules. Start with a clear role and objective. Define the available information and the required process for the task. List permitted and prohibited actions clearly. Set escalation rules for disputed cases to ensure organizational safety. Agentic systems create opportunities, but they also introduce risks that must be managed responsibly. Risks include incorrect reasoning or hallucinations, where the agent generates plausible but unsupported statements. Excessive permissions and prompt injection are also concerns. Treat external content as data, not system instructions. Lack of accountability and automation bias are risks. The organization remains responsible for the system's design. A practical governance program includes ownership, risk classification, human approval, testing, and audit logs. Human in the loop means that a person remains involved in every important stage of the AI agent's process. This means human review before action, exception review, or continuous monitoring with human intervention. An AI agent is more than a chatbot, it is an autonomous action system. Observe, understand, plan, act, evaluate. The future involves humans supervising and collaborating with intelligent systems safely and productively. The essential skill is knowing how to design a process where people and AI work together. Thank you for joining me. In the next chapter, we will continue exploring how AI is transformed into practical organizational capability. See you then.